Hello, everybody. Today we will talk about Chapter 4 Networking and Immersive Technology. And we have three main things to discuss today, starting with the definition and types of networking. Why do we do networking? What are the different types of networking? That's basically what we're going to discuss in our first agenda item. Then secondly, we'll discuss the setting up a home network, how we can install a home Wi-Fi, what are the basic steps, what kind of items do we need in order to install a home network. Then last but not the least is we'll discuss some types of transmission media, internet transmission media, and some networking devices. So starting with the first item, networking. So first of all, what is a network? How do we define a network? So network is nothing. It's basically a collection of computers connected together for exchange of information. So basically, network is the collection of computers, or you can say computing devices, connected together to exchange information and sharing of resources. So basically, network is nothing. We actually combine or collect computers or connect computers with each other so they can exchange information and they can share resources. Now, network can be of mainly two types. There are many types of networks, but again, our book has discussed mainly two types. One is called LAN, local area network. Second is called WAN, wide area network. These are the two main different types of the networking. So LAN, as I mentioned earlier, it's the local area network. And what is a local area network? Local area network is basically a network. It might be a network at your home where you have one Wi-Fi device. This is Wi-Fi router, and with this Wi-Fi router, you might have connected several devices. Maybe this is your computer. That might be your laptop. Excuse me. That might be your cell phone, maybe, or something like that. So this is a local area network where computer or devices are connected within a small geographic area. It could be your home, it could be your office. So local area network is the collection of computers connected together over a small geographic area, such as your office, or it might be your home. So the network at your home is also known as local area network. The next is the wide area network, the second type, WAN, which is wide area network. So wide area network is basically like, for example, if a company has multiple offices. For example, I have one office here at New York, for example, second office maybe, for example, at Georgia. So within one office building, I have one local area network where I have one server and plenty of other computers are connected with that server. At George's office, again, one server, plenty of other computers are connected with that. So if you connect these two local area network using PSTN, public switch telephone network, or you can say internet, that is called wide area network. Okay. So definition is two or more local area networks connected together using public network is wide area network. Okay, that is called wide area network. Or you can say, I mean, the one which I have defined, it's basically the large organizations with multiple offices located across the globe. Okay, but at each location they might have one local area network, and that need to be connected in order to share and exchange information and share resources and all that. The largest wide area network on this planet is internet. So the largest, please remember that, largest WAN on earth is internet, where all the local area networks across the globe are connected. Next, again, using internet, there's a technology which is called EDI, electronic data interchange. For example, when you purchase anything from Walmart. So if you make a purchase through your credit card, so there is an exchange of information between the point of sale, and then the information actually travels all the way over the internet or to your bank or to your financial institute. It follows or it uses a protocol, and that protocol is called EDI. So EDI is electronic data interchange. And as I mentioned earlier, EDI is basically, it allows the electronic communication between, people and the organization. Like organization is basically your financial institute. So it allows electronic communication of business oriented transaction between people and organizations. So that is basically like when you make purchases through your credit card or debit card. So it follows this phenomenon. Next is the packet switching. I believe we discussed packet switching in our internet chapter. Packet switching is basically where we break down the data. Let's say you have 1,000 bits. We break down these bits into small chunks, like maybe 100 bit chunks, and then send the data packet wise. And each packet has the source and destination addresses. The best thing about packet switching is it does not require physical dedicated path. Okay, in fact it requires the shared path, while circuit switching, which is the counterpart of packet switching, is a dedicated path communication model. So now let's understand the circuit switching first. Packet switching is very simple. Just break down the data and send the data packet by packet. While in circuit switching, let's say for example, let me give you an idea. Circuit switching is basically where, let's say for example, you have a landline telephone. Okay, so whenever you pick up the receiver, you just hear a constant tone. That is basically the presence of electrical signal, in fact. So whenever you pick up the receiver, it creates a connection between your telephone line and the local telephone exchange. Local exchange, or you can say local switch. So when you dial the number, what happens? This local exchange will find where you want to call, and it actually transfer your call to that local exchange with which your telephone or the person you're trying to call it, it's basically transfer the call right there. So now what will happen? You dial the number, it will create a channel between your telephone and the local switch, establish a circuit in fact. Then circuit will actually forward the call or make a connection with next exchange where the person whom you're calling to with connected with, and then a physical path will be created. And this path will remain active or remain open unless you hang up your phone call, and no one else can actually access this dedicated channel. Once you finish the call, once you actually hang up your phone, then they can actually use this particular channel. So let me write, this is basically the perfect example of circuit switching. So let me explain you. So this is the example of circuit switching. So what is circuit switching? Let's say when you pick up the receiver, your telephone receiver, it creates and opens a connection to local exchange. Okay, that's the local exchange when you pick up the receiver. Next, when you dial a number, then switch connects to other switches, and this forms a physical path between your phone and the person, that's the person you are calling to. Last is basically when the call is received, a circuit established, and as long as circuit remains open, no one can use the telephone line, in fact. So it will remain open unless you hang up your phone, in fact. Okay. Next is this is all about circuit switching, which is again a very important component or communication model that we use in networking. Remote accessing is if you access organizational resources outside the organization, that is called remote accessing, like accessing organizational resources outside local area network. That is called remote accessing. For example, work from home, like if you want to access server, or maybe for example any web application or print anything from outside the local area network, that's basically called remote accessing. For remote accessing, connection should be secured through authentication. That is very important. So connection should be secured through authentication, and within authentication, what does it mean? Which actually confirms the user and computer, the device through which you are trying to connect. That's basically what the remote accessing should provide. And how we can actually we can get it done, and that's called VPN. So VPN is basically the secure way to access the organization resources. VPN stands for Virtual Private Network. So Virtual Private Network is basically VPN, and what exactly it does. So whenever you actually connect with VPN, so let's say this is your computer. If you're connected with VPN, so what will happen? Now you are connected with this VPN, your organizational secure network, and then you can browse over internet. Okay. So with VPN, what happens? It creates a secure connection between two computers, like you or any device over internet. Second agenda item, that's all about the definition of network and some different attributes of network. Setting up a home network, how we can set up a home network. First of all, we need 3 items to install a home Wi-Fi. So we need three items in order to install home Wi-Fi. First of all, we need internet signal. Internet signal is basically the power, or you can say the signal coming from ISP. Then we need modem, and then we need a router. The modern routers, basically they do come with the embedded modem. Modern routers, in fact, they actually do come with the embedded modems. Like for example, if you purchase internet connection from Comcast, so they don't give you a separate modem. It's basically built in within the router. But some of the companies, they do give a modem, which is basically out. I mean, it's a separate entity. How we install the home network? It's very simple. The first step, let me draw these rather than writing down here. So the first step is right here. You need to connect internet incoming, internet signal to modem. So you need a device, modem. So let's say this is your modem. You need this modem. Okay. So the first step is you need to connect your internet signal, which is coming from ISP, to modem. And then the second step is plug in modem and turn it on. So plug in modem, turn it on. Next, you need to use Ethernet cable, coaxial cable, or something like that, and connect modem with the router. That's, let's say, your router. So the third step is going to be connect modem to router using Ethernet or any kind of you can say networking cable. In fact, fourth step, again, plug in your router. Just plug it in and it will turn it on. Then what will happen? It will start broadcasting Wi-Fi signals. Fifth step is now turn on your computer and locate new Wi-Fi signals. So that's the way how we can connect. These are the 5 main steps how we can install a home Wi-Fi. It's very simple. Next is the transmission media. Transmission media is basically a channel over which internet signal travels. There are many types of transmission media that we already talked about, like DSL, we talked about it, fiber optics. Then we have Ethernet cable. Ethernet cable, you might have seen the blue cables with the Ethernet connector. Microwave, we already talked about all these stuff. Cellular radio and Wi-Fi. So I'll just give you quick overview of all these rather than discussing in detail that we already talked about in internet chapter. So fiber optics, as we already talked about, fiber optic is basically made up of glass material and uses light waves to carry internet signals. Fiber optics, as I mentioned earlier, fiber optics, it offers the largest bandwidth. So of course, if it offers the largest bandwidth, so fastest internet. So it offers the largest bandwidth. So what is a bandwidth? Bandwidth is basically the volume of data that can be carried on internet transmission media. So bandwidth, volume of data that can be carried on internet transmission media, or you can say, or it can also be defined as capacity of transmission media. Capacity of transmission media, like how much data can be transmitted. It is also known as bandwidth. Ethernet cable, you might have seen all those blue cables, which actually has. I mean, if you shred those cable, you will see the twisted pair cable inside those. So these Ethernet cable are used to connect networking devices with each other, devices with each other, and with computers. So if you want to connect any computing device with the network device, you need an Ethernet cable. These Ethernet cables are basically comprised of multiple twisted pair cables. Twisted pair cables, you might have seen those twisted pair cable where the cables are mounted onto each other like crisscrossing. So for example, if you have a category 6 Ethernet cable, it means it has 6 twisted pair cables. Like there will be 6 cables like that, 1 pair, 2 pair, and 3. It will have 6 pair. If you have higher category, automatically it can transmit more data, more bandwidth in fact. Microwave, we already talked about. It's the satellite communication. Satellite communication using microwave frequencies. We already talked about it. Wi-Fi, wireless fidelity is the full name. Wireless fidelity and wireless local area network. It has replaced the wired local area network to wireless local area network in fact. Then the cellular. Cellular, as we know that cellular internet service provider ISP offer data plans using cellular radio frequencies. And what you can do with the data plans, you can watch videos, audios, and all that. There are 4 main companies. AT&T, they offer cellular internet. Verizon, then we have Sprint, then we have T-Mobile. So these are the 4 main companies, and other than these 4 companies, we do have some subsidiaries, like for example Cricket Wireless. We do have some other subsidiaries as well. If you ask for the unlimited data plan from these cellular companies, unlimited data plans could be expensive. And you know what, we are not basically consuming the unlimited data plan. That's very important to understand. Why you are, for example, you only need 40 GB. So why you're asking for unlimited data plan? So in order to find how much data do you need to see currently in use data, and you can find that detail from your bill. So please remember that currently in use data is important to see how much data you need. Last few things are like why some people actually purchase those prepaid connections or prepaid phones. There could be many reasons, or everybody has their own reason. Our book has discussed 3 reasons. Firstly, there is no long-term contract. Secondly, if you just need phone for emergencies or texting or calling, you don't want to use the internet plan, so that could be the reason. Or for example, you don't have good credit history. If you don't have good credit history, automatically, of course, these companies are not going to give you a connection. Of course, it's a postpaid. Typically, the things that are mentioned on your expenses that are mentioned on your phone bill, there are three main things. Please remember these three things: line charges, which is your calling, like the voice calling, in fact; data plan charges, taxes, and surcharges. These are the three main things that are mentioned on your, typically mentioned on your telephone bill. Next, last two things: modem. Modem stand for modulator. So move for modulator, and demodulator. So modulator or demodulator, what it does, it is provided by ISP, and what it does, it converts analog signal to digital and digital to analog. Okay, that's basically what the role of modem is. Then we have router. Router mainly does three things. It connects two networks, like your home network with ISP. It also provides hardware firewall. So basically, if you have a modem, a router, in fact, the router provides you firewall. It connects your home network. This is your home network with ISP. Connect two network, and it incorporates a switch. And what is basically the role of a switch? Switch is basically inside that. Switch connects the devices within local area network. So if your local area network has 3 devices, so switch connect individually all these devices. So switch connects computers or devices within local area network. So within local area network, devices are connected through switches, while devices are connected over the internet using router. Please remember that devices which are connected over internet, they need a router, and if devices wants to connect with each other within local area network, they need a switch. It connects computer within local area network, typically integrated within router. And third, the most important thing is switch actually knows the MAC addresses of the devices. So it ensures, for example, if a data comes for computer A, so when it gets to router, within the router, switch will take the data, and then switch will see the destination MAC address and the IP address, and then transfer the data to concerned computer, not to broadcast the data to all connected devices. Okay, so switch ensures that correct data is transferred to and from the appropriate devices within the network. Please remember, that's the switch. We will discuss continuous switch and router in our next class as well. So if you have any questions, please do let me know.